He's a professor of the Department of Public Finance at the University of Innsbruck in Austria. He also is a co-author of Austrian Climate Assessment Report and also the Special Report on Climate Change and Tourism delivered in 2021. And he also is the editor-in-chief of the Journal of Outdoor Recreation. I met first Robert in Rimini, in Bologna, and from that time we have been trying to arrange his visit to our university. Unfortunately, it has been done. He's spending 3 weeks staying with us, and very open to discuss with all of you about the possibilities to collaborate in different fields of the climate change and tourism research. So today he's going to deliver a very interesting talk about gaps in research regarding climate change and tourism. So please enjoy. Thank you, Robert, for your talk.
Yeah. Thank you, Matthias. Thank you again for the invitation. I already said it on Monday, but I have to repeat it today. I'm really enjoying it here. I also did some tourist tours, of course, in the last days, but I'm trying to use that time to make connections to whoever is interested for potential collaborations. So that's the reason why I'm here. It's my official sabbatical, and something should happen during that sabbatical. So I hope I can use the time that I'm still here. So I will be staying next week. I have to leave on Friday. If anyone is looking for a discussion, talk, or whatever, just let me know. Then we can arrange a meeting in the next days or in the next week. So the talk on Monday was a more general talk on the challenges of climate change, impacts and mitigation. Today I wanted to dive a little bit deeper into potential research gaps and methods, how we could address these gaps, and maybe, so the idea behind that is to give some food for thought for you, maybe, hopefully, that you think, okay, this would be interesting, I could do some research in that, maybe addressing that gap. And as said, if interested, of course, I'm happy to collaborate on any of those topics, or also other topics that are not on my list, of course. So I tried to narrow it down to 5 research gaps. I think I have to disconnect this here. Whoops. Now. Before I come to the research gaps, I think it's important to step a little back and think about what is the relation between weather, climate and climate change, and tourism. I assume that you're quite aware of that because you're doing tourism and or climate change research, but nevertheless, I think it's important to have a look at that before we come to the research gaps. So first of all, for some tourism activities, forms of tourism, there is a physical basis required to do those activities. And in some cases, that physical basis is affected by climate change. So I'm coming from the mountains. I did a lot of my research in snow-based tourism. Snow and also ice is a physical basis that is needed for skiing or for ice skating. If it's becoming warmer, the snow will vanish, and then you just cannot do that activity. I think it would be similar for diving tourism. If you have a large coral bleaching event, then diving is not as, you can still dive, of course, but it's not as interesting anymore. But nevertheless, I think there's still a difference because if you have no snow, you cannot ski, you cannot do it. Although diving, you can still do it, might not be as attractive as with very nice coral reefs, but in theory, you can do it. So we have some resources that are affected by climate change. Then we have the so-called sensory basis for activities, and the colleague, De Freitas, he defined that some decades ago, being the thermal comfort, for example, but also the physical and the aesthetics of climate. So to give you an example, what is meant by that, yesterday I did a tour on the island, and at the end of the tour I was in Maspalomas, and I wanted to do a small walk around the dunes, and then I thought maybe I have a stop at the sea and jump into the water, but yesterday it was quite windy. So the weather was okay, it was nicely and warm, but lying on the beach was a bit, it was sandy, it was windy, and I got covered all over by sand. And this is meant by sensory activities, especially for beach tourism. So you might have nice weather, it might be warm enough, but you have strong winds, so you cannot lie down on the beach, you cannot put up your umbrella for the sun because it's just too windy. Another example would be if you're like hiking, you would like to have a nice view when you're on the mountain. So I was on the Roque Nublo on the other day, and on that day there were no clouds, so it was a perfect hiking day. But if on a day like today, you have still a nice view, but it's not that perfect. And the same if you have a very thick layer of fog, you also don't want to go hiking. And also that kind of resource could be affected by climate change, either positively or also negatively, depending on how often that situation will occur in the future, if it's beneficial or a problem for those tourism activities. And the third aspect is the so-called climate comfort. Behind that lies the assumption, or actually not an assumption, but the fact that the human body can adapt to temperatures by regulating, by sweating and so on, but there's a certain threshold for that. If it's getting too hot, it becomes a health problem. If it's getting too cold, of course, we are freezing. So in both cases, we have some thresholds. And by that it's meant the climate comfort is something where you say, okay, this certain temperature range is acceptable or even ideal for that specific form of tourism. And you might have heard media reports about the question if the Mediterranean is getting too hot for tourism, and this is actually what this aspect is about. So would climate change bring a negative impact for Mediterranean tourism, for example, because it's getting too hot? Or might it be beneficial, on the other hand, for Nordic countries during the summertime, which might become more attractive for tourism? And in between that, so it's not only the question, it's not binary, it's not yes, no. Is it good or bad? Do we have the resource? Let's take snow again. Do we have snow or don't we have snow? It's also about the quality of that resource. So you can have a very warm day, you can have lots of snow, but if it's too warm, the snow gets very soft. And it's more difficult to ski, it's not as easy and not as joyful. And then you have a declining quality of your product, although you have enough snow. The same maybe for diving. You might still have a coral reef, but if there's only, let's say, one species instead of 10 or 20, it's also not that attractive maybe. Then there's also the quantity of the resource. That could be, for example, biodiversity. If you're interested in bird watching or wildlife watching, wildlife tourism, you would rather like to see very high amount of different species and a lot of animals, and not only see one animal within 1 week or so. And then there's variability that we have to take into account. Usually when we are doing climate change studies, we always look at an average, at a 30-year average, and that average will change in the next decades. However, what we experience as humans is weather or weather variations. So as you all know, not every summer is like the other, not every winter is like the other, so we have that variability, and that variability is also changing with climate change. And the question is, what does that do to our experience as tourists? So if we experience a too hot summer, would we then decide not to go to that destination again? Or how many hot summers does it need for us to change our travel decision? So this is what is meant here by variability. And if you look at that, then that entire topic is becoming quite complex. And of course, there are also other factors that affect tourism, and not only climate change, of course. So everything is interconnected. Now, I'd like to talk about those 5 topics and/or research gaps and potential ways to address those gaps. Maybe not solutions, but ways to investigate those gaps. And I'd like to start with the climate change impact indicators. So this is the so-called Tourism Climate Index. And this is an index that combines temperature, precipitation, sunshine duration, and I think cloudiness is also in that index. And the higher the index, the better the climate for tourism. So this is kind of a suitability index for tourism. And in this definition, it's about some kind of general tourism, and it's called sightseeing tourism, whatever that is. But in the original development, it was meant to be a very general tourism for the suitability. And this is now data for Europe. I don't know why some regions are missing, like here, example in Portugal. I didn't check it, so I just downloaded the data and made that map. And now if you look here, this is the TCI for the month of August in the period 1980 to 2010. And if you believe that index, you could say that the tourism climate is, if you look at mainland Spain, is better in the interior of Spain compared to the coasts. So here we have to ask ourselves, okay, how is that index empirically validated or not? Because, I mean, I've been traveling through Spain, I think 2 years ago or so. We went from Barcelona to Portugal by car in August, and I can say it was much more comfortable at the coast compared to the interior of Spain, of course, because we had 43 degrees in Madrid. So something seems to be not quite okay here. Also, if you look at other countries, it's the same in Italy. And then when looking to my area, so this is more or less, this is Austria. And you see that the rating is moderate. You have something like in this range here at around 50, which is acceptable, or even marginal if it's below 50. Now, if we assume that that indicator is correct, then we would have to see that there's actually not much tourism in August in Austria. But in fact, we have 75 million overnight stays in the summer half year, so not in August, but the entire summer half year, which is quite a lot. We have 9 million inhabitants and 75 million overnight stays, so we are very tourism intense. And even if you go further west, so this is my federal state, Tyrol, a very mountainous federal state, there we have 23 million overnight stays and 700,000 inhabitants. So I think the tourism intensity in our federal state is higher than on the Canary Islands, and you know how tourism intense your area is, you know? So we are even a bit more tourism intense. So if that index would be correct, why would we have so many overnight stays? So something seems to be wrong or not 100% correct looking at that index. Although it's a very nice tool to have a look at potential suitability and also to have a look at changes, because that data is also available for different climate scenarios, for different future periods, and so on. But before we do that, and there were quite a lot of studies using that TCI for different regions in the world, estimating potential impacts of climate change on tourism. Before we do that, we need to be sure that that index actually is useful for that specific topic. We did a small study with a sample of tourists in Austria and had a look at different activities during their holiday and acceptable temperature ranges. And I don't want to go through that in detail, but only maybe have a look at water sports. So we also have some kind of water sports. We have some lakes in the mountains. And here what you would expect is that the threshold for a perceived too hot temperature is considerably higher, as example for hiking or for mountain climbing and those kind of things. And the same for the threshold for too cold perceived temperatures. And the difference here for water sports and most of the other activities is around 4 degrees. So if you look here, for too hot, it's around 32 degrees is perceived as too hot, whereas here, for the more active segments, it's 28, which is perceived as too hot. So or is it 2 degrees? No, it's 4 degrees. 4 degrees difference. So within tourism, for different activities, we have a difference of 4 degrees centigrade, what is perceived as too hot. So how much climate change signal do we have to expect for the upcoming decades? At maximum +4 until the end of the century. So it would be too easy to say, okay, we have a climate change signal of 4 degrees, and we assume that tourism or the suitability for tourism is declining, we cannot just say that. It depends on the tourism activity we look at. And then, of course, the question on how much a region would be affected by that depends on the share of those single tourism activities in the region. And then, of course, as a destination, you would have the possibility to change your customer group, to say, okay, we used to have a focus on very active tourism where people do a lot of sports and so on, and therefore the suitability becomes worse because it's getting too hot. Why do we not switch to water-based tourism if we have the conditions for that, if we do have the lakes? So there are options to react to a changing climate also for destinations. And another thing with that indices is that up to now, it does not account for vertical differences. So this is a picture taken where I'm based in Innsbruck. So this, it's a bit bright here. So this down in the valley is Innsbruck. And we have mountains around town that go up to 2,500 meters. So we have about 2,000 meters vertical difference between the valley bottom and the top of the mountains. And as you may know, it's getting colder if you go up the mountain, of course. Now this is not measured data, it's just kind of a belly feeling I have what it looks like. So on a typical summer day, we have night temperatures of around 15 degrees in the city and about 30 degrees, maybe a bit more on some days during the day, maximum temperature. But if you go up the mountain, as said, about 2,000 meters, how you can go up, then temperature is going down. So you have a maximum temperature of something like 16, 17 degrees on the mountaintop if it's a really, really hot day. So if you are applying a tourism index, that is where temperature is a very important part of that index, where do you apply that index? Do you apply it at the valley bottom? And you would say if it's going beyond 30 degrees, that would be a too hot day, so not good for tourism. But the tourist can escape, he can go up the mountain. And you even do not have to walk and hike up the mountain, which is then, of course, exhausting and so on. You can take the cable car and be in 10 minutes on the mountaintop. So you can escape the heat. And this is not considered in all of those kinds of indices. So this is also something that would have to be done for the specific form of tourism, in this case of mountain tourism, at least for the summer season. So my first conclusion or my first research gap is that we need more activity-specific assessments of climate suitability. So what I showed before, maybe a specific indicator for water-based sports and so on, more active sports. And also we need to account for topography in those indicators, at least if we are doing those kind of assessments for mountainous areas. And you have seen the Europe map before, of course. We have many mountains in that area. We have the Alps, we have the Pyrenees, and so on and so on. And another thing that is, or a follow-up question to those climate change impact indicators, here a study of colleagues on the Canary Islands. And here the analysis was only on excellent and ideal days, so days above the value of 80, above 80 TCI. And you can see if you look at summer that, you can best see it in Fuerteventura, that the number of ideal days in summer will decline in Fuerteventura because it's becoming too hot in the summer months. Whereas in the winter months, it's actually improving all over the Canary Islands because, you get more ideal days in wintertime because it's getting warmer. Okay, but what does that mean for tourist destinations? Does that automatically mean that we will have more tourism demand in those months, more or less tourism demand, depending on which season you look at? We don't know. We don't have evidence for that. So even if your suitability is changing, that does not mean automatically mean anything for demand, for the demand side. And this is also an important aspect that we have to look at, because this, in the end, is what matters. If any destination has a positive or a negative impact by climate change. Now, this is a bit small, but the details are not super important. This is one of the few studies that actually looked at correlations between extraordinary weather and tourism demand on overnight stays. And this is a so-called revealed preference study. So these colleagues analyzed weather patterns during the summer months. You can see here in the top, so one indicator was the number of days above 25 degrees maximum temperature. The other one was the number of days above the 80th percentile of temperature, and so on and so on. And then we have all those regions in Switzerland, that's the so-called cantons, so the administrative regions in Switzerland. And they took the overnight stays and just made a simple correlation. Do we find any correlation between those number of warm days and the overnight stays? And everything that is colored, there a statistically significant correlation was found. And the correlation is, the highest correlations are somewhere around 0.7, 0.8. So it's really quite a clear relationship between those two variables. And you see that the topmost regions here have quite a lot of significant relationships here. So there seems to be some kind of relationship between overnight stays and weather or heat, warm days. And I found that the regions that are on the top are in the vicinity of metropolitan areas. So it's not the destinations that are rather far apart in Switzerland and high up. It's rather the destinations that are in vicinity. So you can escape the city for the weekend, maybe have 1 or 2 overnight stays in a mountain destination that is 1,000 meters higher up. You can sleep without air conditioning, you can sleep with open windows and enjoy the cool days, and then you go back to the city. We also did some kind of revealed preference study for the topic of winter tourism in Austria, and we used the so-called analog approach. So we took one climatically extreme season, winter season, and just descriptively analyzed what happened to tourism demand in that extraordinary season. And we took the winter 2006-2007, which was about 3 degrees above the climatic average. And up to now, this has been the warmest winter ever recorded in the Alps since we have measurements. And this is an analysis for the so-called lift transport in ski areas, so that's visitors in the ski areas. And you see that we had some ski areas that had losses of more than 50% in that entire season. So you lose more than 50% of your revenues, which is quite dramatic, or has been quite dramatic for those ski areas. At the average, there were losses of 30% overall ski areas, which is quite a serious incident. So we see some clear effect. We also see some kind of regional pattern, though the ski areas in the northern parts were more heavily affected. This is due to the fact that those ski areas are lower altitude, and therefore we're more affected by the lack of snow and by the too high temperatures. And it's also that smaller ski areas had bigger demand declines than larger ski areas, but there's a kind of autocorrelation because the larger ski areas are usually at higher altitudes. And we also had a look at the overnight stays. There the declines were not as dramatic as for the skier visits in the ski areas, but we still had declines at average of 10% in the entire federal state, and we had losses of more than 10% in some of the regions. This here, for example, is the region where Kitzbühel is located, one of the most renowned ski resorts that we have. Why is the demand decline not as, in overnight stays, not as high as for skier visits? That's quite easy to explain, that I found the word. So imagine you're booking a holiday. Usually you book your holiday several months before you go there, because if you want to book for the next week, you don't find a room, usually if it's the high season, or otherwise they're doing something wrong in that destination. So you book like half in a year in advance. So you book your winter holiday in July or August. You, of course, don't know how the snow situation will be. Then you see that the winter is not very good. It's too warm. We do have a lack of snow. What do? The holiday is 1 month from now. Should we cancel the holiday or not? We still would like to go on holiday. You know, it's our family holiday every year. No, the snow will come. We will go. And then it's 1 week before your holiday, and you see, okay, it's not good. The snow is bad. So should we cancel our holiday? Okay, now we will lose money, because we paid 4,000 euro for that holiday. If we cancel now, we don't get any refund. So people still go there. They hope they still can ski. Maybe they ski less often as they usually do. They go maybe only 3 or 4 days instead of an entire week. This is why the skier visits went down, but they still go on the holiday, at least most of them. This is why the reaction in the overnight sector is less sensitive to those changes, although we don't know how it would look like in the upcoming years. So if something like that is happening 2, 3, 4 years in a series, then the question would be interesting, what then happens to demand? And there's also a regression analysis with that kind of data. So this study used snow depth measurements in the destinations and overnight stays. And you see all of those black circles. There we have significant effects that were found, most of them being positive, meaning less snow means less overnight stays. In some destinations, it's inverse, so less snow means more overnight stays. That's usually one of the few high altitude ski areas. So they benefit in lack of snow years because their competitive advantage is just better compared to the rest of the market. But you see there are also a lot of white circles where the model failed the diagnostic checking. And a different study also showed that that kind of relationship between snow and overnight stays declined in a time series of 30 years. And it's assumed that this may be, or is very likely be, to the fact that now we have a lot of snowmaking, of machine-made snow in the destinations, so we're not anymore that dependent on natural snow. But there seems to be some connection, at least in quite a high number of areas. But unfortunately, there are not that many studies around, neither for winter nor for summer tourism, and this is why I would say we need more of that revealed preference studies to also make use of an increasing occurrence of extraordinary weather situations. So we see more and more extremes. We have seen the hottest summer so far in the Mediterranean. We have seen forest fires in quite large parts of the Mediterranean in the last summers. We could use those extremes as kind of a natural experiment and to do analysis of how did tourism demand react to that extraordinary situations. The challenge we face when doing that is the temporal resolution of tourism statistics of overnight stays. So usually you have it for the summer half year, the winter half year. If you have good data, you might have monthly data. I have not seen data that is better than monthly data. Monthly is quite okay. But again, from a weather perspective, then you would have to find months, an entire month that was extraordinarily warm. It's not enough to have 1 or 2 hot weeks. You should have 4 weeks, because otherwise you could balance out somehow from a weather or from a climate perspective. And you also have to see it from a tourism perspective. I do not stay 4 weeks in a destination. I stay there for 1 week, maybe 2 weeks maximum. So I will experience the weather for a week or 2. And so here, tourism statistics do not match tourism experience and also do not match what the weather was like. And one problem of those kind of revealed preference studies is that we cannot capture the impact of new yet unexperienced extremes in the regression models. So I assume that you know what regression models are. Nevertheless, I'd like to show that. So you do a regression, tourism demand on temperature, then you have those single years here, and then you can do that kind of linear regression analysis. And then the question is, so this is past climate, and then you want to know how would tourism demand develop in a future climate. Yeah, if you only have those points, you would assume that tourism demand will benefit, will increase if the climate is getting warmer. Something like that maybe. But in theory, there could be a turning point in all of the data in time series. It could be that it's getting too hot for tourists, but we have not had that incident in the past. But it could be in the future, but we don't know. So the actual future might be anything like that. It could be anything like that if we have a turning point that is not captured in our data that we have available. And this is a basic problem with climate change, where, which is a challenge to that kind of regression techniques. Although, as said, we have more and more of those new extremes popping up, and we could try to make use of those extremes as natural experiments. And with that, I'd like to switch to stated preference studies. So usually an economist would say you should rather use revealed preference studies, so at least that's what we get as a very frequent review or comment. If we're doing stated preference studies, why don't you use revealed preference? And as said, there are situations that are not captured with existing data, so hypothetical future scenarios. And for those kind of analysis, you can use stated or should use stated preference studies because there's hardly any alternative. And here are an example of some choice experiments, or one example of a choice experiment that we conducted 1-2 years ago. More on the topic of energy consumption in hotels, more of sustainability aspects, climate mitigation aspects. So the background of that study was we had the Russian aggression war, or we have the Russian aggression war on the Ukraine, and then we had a lack of energy, or there was the fear that we will have an energy crisis in the upcoming winter of 2022, I think it was. And there were discussions going on the political level in Germany as well as in Austria if there should be a law that reduces the heating, or that reduces the temperature in the buildings for the next winter season. In Germany, for example, it was decided that in public buildings the maximum temperature should only be 19 degrees centigrade. And there were discussions going on if such kind of rule should also be applied for the hotel sector and also for the private sector. It was not implemented, but it was discussed at least. And this is why we took that as, so you could say, as a kind of framing. And then we wanted to know, okay, how do tourists react to the current energy crisis? And would they be willing to reduce or to accept lower room temperatures, knowing that we have an upcoming, or might have an upcoming energy crisis, and we have skyrocketing energy prices, and would that situation increase the acceptance of low room temperatures? So we did a choice experiment with more attributes than I show here. I just want to have a look at power supply and room temperature. And then we did a clustering analysis to see if there are any differences in the sample, and of course there are. So maybe have a look, let's have a look at the power supply. So here the question is, where does the hotel get its energy from? From the public grid, which is fossil fuel based, or does it buy green energy, renewable energy, or does the hotel produce its own energy with a biomass generator, or with wind turbine, or with solar power, or whatever? And the other attribute was, what room temperature would you accept? And what you see here are the part worth utilities. So the higher the value, the more accepted that characteristic would be. And you can see here a distinct difference between those two clusters, so that the blue cluster, you can see, would be an environmentally or climate aware cluster, you could call it. They favor very much green energy or own production, whereas the other cluster, the difference is not so much between those two levels. It's a bit higher than for fossil fuel, but then green energy or own consumption, it actually doesn't matter. And even more interestingly, in our view, is that the blue cluster here, cluster number 1, it doesn't matter if you have a room temperature of 22 or 20 degrees. The attractiveness is practically the same. So as a concluding message of that study, it was, if you are able to buy green energy or to produce your own renewable energy in the hotel, you would be able to lower your room temperature, so force the guests that the room temperature is lower, and you would still be as attractive as competitors who have fossil fuel-based energy system in a hotel and have higher room temperatures. So we see that there is some potential to apply those kind of energy saving measures in the hotel sector. And you could, of course, do similar experiments according to heat perception and all those kind of things that I talked about before. So another idea with that, or related to that idea, is, for example, how do tourists perceive renewable energy production in a tourism destination? And this is, I would say, especially important for island destinations, as you're not connected to the power grid of the mainland. So you have to produce your own energy. And usually in island destinations, you have quite a high potential for renewable energies, be it wind energy or solar power energy. But then in the end, the question is, would tourists perceive that positively or negatively? Because it's always also an impact on landscape aesthetics, be it onshore or offshore renewable energy production. And there's quite some studies around that are looking at preferences of the local population, what is important, of course, because they have to live with that the entire year. But there's way fewer studies investigating tourists' perception of those kind of renewable energies. So my third gap is that we need also more stated preference studies where we can investigate future conditions that cannot be captured by revealed preference studies, so hypothetical scenarios. What we have to keep in mind, of course, are the challenges that we always have with stated preference studies, the intention behavior gap, so people act differently to what they say they would do when they're doing a survey or an experiment. And we have to try to reduce that potential error, and of course social desirability, especially if it's about climate protection and especially if it's about environmental issues and sustainability. There the social desirability is quite high. So the risk that people say, oh yeah, I'm an environmentalist, and he actually is not, that risk is relatively high in those topics. And we have to be aware of that fact. So my fourth research gap relates to integrating supply and demand side adaptation. So most of the research that we have is focusing on either one of them. So you're either investigating how is the supply side affected by climate change, how can they adapt to that, or you focus on the demand side, how do tourists adapt, and what are the impacts on tourists due to climate change. But as you all know, of course, this is kind of a interrelated, these are interrelated actors. So the demand side reacts to changes on the supply side and the other way around. Yeah? Of course, so we're in a competitive environment, and in an ideal world, scientific world, we would say, okay, we have to investigate that on a more broad, on a more comprehensive level and integrate supply and demand side in our climate change impact assessments. So we should not assume that all those actors are stable and are not doing anything, and that they are affected by climate change and cannot do anything, because of course they can do. Here one example, so there are some examples around. Here's something that we did, and I showed because I know the details, and if there are questions I can talk about those details. So we did a large-scale survey, including a choice experiment with skiers in Austria, so a sample of roughly 4,000 people. So that was the stated preference part of the study. Then we had supply-side impact modeling, so the map I showed beforehand. No, I did not show it. It was on Monday. We did supply-side impact modeling, so we had a look at how does climate change affect the reliability of ski areas, snow reliability of ski areas. So what is the impact on the supply side? And then we combined that and developed an agent-based model where we simulated the redistribution of demand based on different development paths. So our agents were tourists, and we had destinations, so objects in that agent-based model. So tourists had to choose ski areas where they would have a skiing holiday based on the results of that survey and based on the rate of snow reliability of that ski resort, and that snow reliability would change in the future due to climate change. And then we defined different development paths because we said, okay, we have to assume that the supply side is reacting to that potential risk. And we defined 4 different development paths together with stakeholders from the tourism industry. So the first development path would be everything stays the same. We do not have more investments into snowmaking, so into adaptation. And all ski areas would remain on the market, which is rather unrealistic because if you have a shortening ski season, then it's quite likely that some of the ski areas would have to drop out of the market and close their business. But this was everything stays the same except that climate changes. Then development path number 2 is that high-risk ski areas close permanently because they're losing their customer base. So we have fewer ski areas on the market. So the competition on the market would change in this case. The third development path was that all ski areas increase their snowmaking capacity, so they become more resilient against climate change impacts. But this means they have to increase their prices. So the product gets more expensive. And price was also included in our choice experiment. So we knew what price change would make or would mean for demand change. And the last scenarios, like the third one, so all ski areas increase snowmaking capacity, but the high-risk ski areas close permanently. And of course, you could have 10, 15, or 20 development paths. So we had that many, but then we cut it down to 4 just to make it kind of somehow digestible, the results. And I cannot, of course, not go into detail. I just want to show this here. So this is now the simulated changes of skiing demand in Austrian regions that have ski areas in one particular climate scenario on one time period, and the 4 development paths. Maybe have a look only at this region here. It's called East Tyrol. Here in this scenario, we would have an increase of skier visits. Here the increase would even be stronger, and here we would have a decline in those 2 development paths. We would see a decline of skier demand. So we cannot say how accurate that results are, and this is also why we did not publish it. But this just shows the results of how demand would evolve are very much dependent on the assumptions you have how the market develops. And how the market develops is an interaction between the supply and the demand side. And this is why we have to have more investigations on that demand supply side topic. Because then we can consider more dynamics in our assessments and be potentially more realistic in our assessments. And the last points I have is to have a more analysis on tourism markets and a more system perspective of the challenge of climate change that we have. So let's have again a look at the Tourism Climate Index. And let's assume that index is correct and so on. So we have some source markets, the UK, France, Germany, or the Scandinavian countries, and they have some preferred destinations. So the UK guys go to Costa del Sol, people from Paris go to the Côte d'Azur, Germans go to the area of Jesolo or Rimini, and the Scandinavians go to Greece nowadays. Now let's assume it's getting too hot in that area, as we have discussed beforehand. Now the question is, what happens? So what research is looking at is mainly this here, what happens to those areas? What is the potential demand decline? And even there's not much research on that topic. But even more interesting, or on top of that, what is also interesting is where do people go in the future? So people from Paris could decide to go to the Atlantic coast. People from mainland Spain could decide to go to the Pyrenees instead of going to the Costa Dorada. Germans could go to the Alps, or they could go to the Baltic Sea. So this would have an impact on not only on those destinations, of course, but on all destinations potentially in Europe, and not also in Europe, of course, but on a global scale. That is one thing, so that's about the tourism market. And the second thought I have on that is what happens with greenhouse gas emissions. So if you imagine the long arrows we had beforehand, Scandinavians going to Greece. Now when they go have holiday in their own country, or if they go to the Atlantic, the travel distance would decrease, and therefore their greenhouse gas emissions might change. But it could also be that they go somewhere else, that they go to the Canary Islands, and then their greenhouse gas emissions would increase. And here's something that we investigated for the US, or for the North American market. There we had that ski studies I showed before, and here it's the case that we have some quite important ski areas in this area. So this is Ontario in Canada, and this is the Midwest in the US. So the Great Lakes region, Chicago, that area. And there are some ski areas that have quite a high number of skier visits, but they are low altitude and they are quite sensitive to climatic changes. Now let's assume a future where it's becoming too hot and those ski areas would have to close. What would skiers do? Some of the skiers might decide, okay, we don't ski anymore, we just stay at home. So from a climate perspective, this would be good. They do not produce more greenhouse gases. But a certain share of customers, and we don't know that share, might decide to go to Quebec, where we still have ski areas. A certain share might decide to go west to the Rocky Mountains, Canadians or US Rocky Mountains. To those ski areas you cannot go by car, or you do not want to go by car, like in those ski areas, there you have to fly. And of course, as soon as you switch your mode of transport from car to plane, your greenhouse gas emissions skyrocket. And we also have to consider that, especially when we are trying to identify if an adaptation measure is adaptation, a successful adaptation, or maladaptation. So in the case of snowmaking, at least in our area, so the German-speaking market, every year there's a lot of discussion going on. Should we still be allowed to produce snow because it's energy intensive and so on? And of course you can discuss that question, but you also have to investigate that question. What would happen if we do not produce the snow? What then happens to tourism demand? What do people do? As said, if they would stay at home, we could say, okay, from a climate perspective, that's perfect. But that's rather unlikely because people want to travel and they want to have their winter and skiing holiday. So we have to think about potential maladaptation, but also potential rebound effects. That what was I meant with the increasing emissions. Those are so-called rebound effects. So the last gap I have is that we need more studies focusing on that markets, those entire tourism markets, also considering competition. And we need an investigation of climate impacts on more than just one system, one subsystem of the tourism system. So not only look at the supply side and investigating that isolated, not only looking at the demand side, but trying to bring that together, also in a bigger geographical market. And with that, I'd like to conclude. I do not want to read all of those gaps again. We have seen them before, but maybe that's now the basis for a discussion that we can have, or of course, any other ideas or questions that you have on that topic. Thank you very much.
Thank you.
Well, I mean, I'm still like going through my notes and everything. Actually, well, I'm going to ask a question. Actually, yesterday I was looking through your paper from the 2025, the Titan TAT. Yes, the Team for TAT, where you were talking about before that you did a chess experiment. As well, you used another methodology, right, in that paper, right? But you didn't explain that part today, right?
No. Because that was a part of a colleague, and I'm not into the study two that we had in the paper. So there, my colleague is the expert on that experimental design.
Okay, yeah, I mean, because I was going through and I actually didn't understand the wall, so that's fine.
Yeah.
Great presentation. I have a question because I saw that different parameters are important to measure when we talk about climate change and the effect in tourism. But I think one of the gaps that I didn't see were like how wildlife tourism could be affected, because actually I think the rest of effects of climate change could be easier to manage. But when we talk about wildlife, it's just 1 degree change everything, the whole ecosystem. So yes, maybe you can give us an insight about it.
I'm not sure. So we did some review studies, and we had that topic of wildlife/biodiversity as a resource for tourism. We had that in there. But if I remember it right, there were not many studies on that topic. I think the challenge is kind of the same that we have with those topics. So first of all, you have to see, can we reliably model the impact of climate change on wildlife, be it the number of species and so on. So how reliable is that we are doing there? And then the question is, how would that translate to tourism? And then, of course, as you said, how can we adapt to that? And I'm not an expert I'm not an ecologist, so I don't know in what sense how wildlife could adapt or how we could support wildlife to adapt to that. I think that adaptation would be in the tourism system, that you would have to switch from wildlife tourism-based form of tourism to a different form, which would of course mean a total transitioning of your system. So if you have, I don't know, whale watching, which is very important at a certain destination, and the whales do not come anymore because, I don't know, I'm not a whale expert, but it's too warm or whatever, then I mean, you can build artificial whale watching attractions, of course, but in the end, to watch them in wildlife, you cannot do anything about it, I assume. But as far as I remember, there's also not much on that. So I think you would need to have a destination that's very dependent on wildlife tourism, bird watching, fishing, whatever, and then have a look, do a combined analysis on the supply side impacts and also on the demand side impacts. But I think very interesting, yeah, of course.
Yes, I do have a question.
Yeah.
It's actually about the gap too. You said there's a part of the gap is that the tourist statistics not match the amount of info that you have, for example, from the weather statistics, right? And you say that there is no tourist statistics that go better than weekly, right? If I'm not mistaken.
I only know tourism statistics that are on a monthly basis. Maybe there are better ones on a weekly basis or 2 weeks basis, but I only know monthly basis. You can still work with that kind of data, but of course we would like to have better resolution of that, because then the resolution of climate data would match the tourism resolution. That is the challenge, I think.
But for example, because actually I was going through literature in terms of heat waves and everything, and actually AMET is the, how do you call it, is the weather institution from Spain. Mm-hmm. There is they did a report in heat wave from 1975 until today, mm-hmm. And they published the times there is a heat wave, right? It's for 1 day, 2 days, or a week, mm-hmm. or mm-hmm. A long day. In case, that's my question. So for a future paper, we can use that information even though we don't have a weekly or a 2 weekly statistics. For example, if 1 month is extremely hot, in 1 year, then 2 years later is another month extremely hot, we can match that with the tourist statistic, or still it's really weak, or.
I think you can do it and you should do it, but the challenge is that maybe the tourism statistic resolution is not high enough to identify what you want to identify, but we do not know. We would have to try that and see what happens. And of course, I think you would have some, in that case, heat waves that are longer lasting, that last for several weeks. And then I would assume that if there is any effect on demand, you should be able to identify that, but maybe not of heat waves that go 3-5 days, but of longer lasting heat waves. And then the question is, how many of those heat waves do we have in a time series? Is it only once in 30 years, or do we have it every 3-4 years? So the more often you have that, the higher the chances that you really are able to identify an effect, if there is any effect existing. But that's a black box, so you don't know what. It can also happen that in the end you will say, okay, we don't see any effect in the data we have. Yeah. So that's it then.
Well, thank you for your talk. Just while listening, I was wondering what is your opinion about that as a geographer? Just because I know that correctly, you come from that field of knowledge. Climate change is formed by two different words. One is climate and another one is change. The question is just shedding light